Very good morning. So in this particular video, I'm going to give you information regarding that various biochemical changes that is took place in the seed system at the time of that seed germinations. So in the previous videos and all, we were discussed about the matter related to that seed development and maturation. So at the time of maturation, what is happening inside the seed is storing of that food material, that too in the form of a complex carbohydrate and polypeptides and lipids. So all the three under its condensed format that and all produced through the metabolic activity, that is through photosynthesis process. After photosynthesis process, all those materials are condensed and tightly packed in the seed system. Whereas that seed germination is the opposite to that photosynthesis process. If you consider photosynthesis as a metabolic process or synthetic oriented, means germination is a degradation related, because germination is a energy demanding and that seed system also need energy in the form of ATP. So for generation of the ATP, for having that energy for carrying out that reassumption of that embryo growth and cell elongation and giving size and shape for the young root, that plumule and radicle. And once that elongation everything took place, that whatever that root and shoot develop, that should be rupture the seed coat and that should come out of the seed system. So everything here, it's a energy oriented process. So for all these things, the systems, particularly the embryo, that need ATP. So for generation of the ATP, whatever that food material stored in the form of starch or fat, that should be converted into glucose. That glucose should be enter into the glycolysis process that should generate the ATP. So with the help of that ATP alone, that seed, particularly that embryo, able to give rise a seedling. So germination as a catabolic process, that is breakdown of the stored food material for the purpose of giving energy molecule to the embryo to give rise a seedling. So this is totally opposite to that photosynthesis process. So that germination, so many definition given by the person working in the different field. In that I have given definition based on that seed physiologist point of view and seed analysis point of view. The seed physiologist point of view, germination is defined as emergence of the radicle through the seed coat. So it's a mere emergence of the radicle through seed coat. But seed analysis point of view or seed technologist point of view, they are very much concerned about the resultant seedlings, that is production of normal plant under favorable conditions. So that is a thing given by the seed analysis, that is a production of normal seedling under favorable condition. Actually this definition given by the Association of Official Seed Analysts during the year 2000, because they are very much worried about that outcome of the seeds, outcome of the germination. If it is a normal, then only normal seedling, then only they will consider that seed as a germinable. If it is whatever that seedling that come out of the seed through germination process, if it is a abnormal, they never consider that particular seed as a germinable one. So here the definition is mainly based on the result. If it is normal, that will be a normal seedling, that will be a germinable seeds. If it is abnormal, that will be a non-germinable. They will treat that particular seeds equal to a dead seeds. So these are all the definition given by the two different field in a separate perspectives. So these are all the different phases of the seed germination. So the seed germination, so that undergo that 5 different phases. And that first one is imbibition, followed by activation of the enzymes, and that activation of enzymes leads to degradation of the stored food material, that is a complex material converted into a simple material. Then simple material will be entered into the glycolysis process, that will generate the energy molecule ATP. that will be supplied to the embryo for initiation of its growth, for reassumption of its growth. So here that embryo will undergo that cell multiplication and elongation, side by side, that organogenesis, that is a root and shoot formations. Once that elongation, cell elongation take place, means the seed coat not able to withhold that structural integrity. Slowly the developing radicle and plumule also will rupture the seed coat, and finally that seed will give rise that seedling, that is emergence of the seedling. So these are all the 5 different phases of the seed germination, that is imbibition, enzyme activation, initiation of the embryo growth, rupturing of the seed coat, and emergence of the seedling. So in that that imbibition process is a very, very important process. Yes, that is the starting point. If at all any failure, if at all the seeds are not able to imbibe in the water, means so the seed systems are not able to initiate that germination related process. So the imbibition is very, very important. Imbibition means through the process of imbibitions, water going to enter into the seed system, and that ultimately going to increase the moisture content of the seeds. So the entry of the water into the seed system is mainly governed by the three major component, like biochemical constituent of the seeds, seed coat permeability, water availability, and quality of water available. So these are all the 3 major components. Apart from that, so many factors are there, but these 3 factors are considered to be a major factor with reference to entry of the water into the seed system at the time of the germination process. And that the first one is biochemical composition of the seeds. This particular thing also play a major role with reference to regulation of the water entry into the seed system during the process of the imbibitions. So already we have a classification of the seeds that is mainly based on the biochemical constituents. So we classified that total seed into a 3 category, that is that cereals, pulses, and oil seeds. So this classification is mainly based on the biochemical constituent of the seeds. Particularly if you say one metal is a cereal, means definitely that will have more amount of the carbohydrate. If you say one metal is a pulses, mean that will have a higher amount of the protein. If you say one seed is oil seed, means definitely that will have a more amount of the fat or oil content. So this classification is mainly based on the biochemical constituent of the seeds. So the biochemical constituents of the seeds also play an important role with reference to imbibition process. For your information, whatever the seed in which that have a more amount of the protein, the rate of water entry into the seed system will be very faster rate. So rate of uptaking of water is very, very fast. At the same time, that will ooze out that water also at a same speed. So because of that, if you soak the seeds of that black gram or green gram or any pulses in the water, that will very quickly absorb. Within 2 or 3 hours of time, you can see rupturing of the seed coat and protruding of the radicle. So this clearly indicates that protein molecule have a greater affinity towards the water, so that will very quickly absorb the moisture content. So in the case of pulses, for doing at the time of soaking, you have to pay more attention, or otherwise that seed will get damaged. So that protein, you have to do it in a very controlled way. Then only you can make your seed still alive until that emergence of the seedling, or otherwise that quick absorption of that moisture due to presence of the protein, that will make say there may be a structural collapse with reference to that seed coat structures before that initiation of that remaining process, like enzyme activation, embryo growth, and everything. So before enzyme activation or that embryo growth, before that, if at all anything happened to that seed coat, so definitely that seed not able to give rise any seedlings. The total system will be collapsed. The seed coat should rupture only at the time of emergence of the radicle. So that is the right thing. Before rupturing of the seed coat, any of the remaining 4 different phases of the seed germination, definitely that seeds not able to give rise any normal seedling or not able to produce any seedling. So during the process of the imbibitions, we have to ensure the maintenance of the structural integrity, particularly the seed coat, seed membrane integrity should be maintained. Then only that process will be pakka, the outcome will be a seedling, or otherwise we won't get proper germinations. So whereas that carbohydrate, that cereal seeds, suppose if it is in the form of starch, or the carbohydrate blended with any fiber matter, means there that rate of water entry will be slow. Suppose that endosome is fully packed with that porous endosome, that is a divide of any fiber matter, only that carbohydrate, means there also we can expect that faster rate of water entry into the seed system. In those cases we have to pay attention like that of the pulses. Whereas in the case of oil seed, that rate of intake will be suppose that oil is a major and a lesser amount of the protein and carbohydrate, means that is somewhat repulsive nature, but the crop like groundnut that have planted with good amount of the protein also. So because of that, there also you can experience that the quicker water intake. So this and all that here this protein, carbohydrate and oil that also regulate that rate of imbibition or rate of water entry into the seed system at the time during the process of the imbibition. The next factor is seed coat permeability. So here if you are looking for getting good quality seedlings out of this germination process, means you have to ensure that the entry of water is only through the seed coat. The seed coat have a semi-permeable membrane. The water entry is regulated through the seed coat, means definitely there won't be any problem, the germination will be pakka. So if at all any damages are there in the seed coat, at the time definitely the water will enter into the seed system through mass flow action. If at all the water going to enter into the seed system through mass flow action, means definitely that will kill the seeds, that never support the seeds to enter into the remaining process of the germination process. So here that water entry should be through the semi-permeable membrane that is available in the seed coat. So that is a very very important one. Then water availability and quality of water, that also going to play a major role, that and all we can discuss that below given 3 points. Then the ability to imbibe water is depend on cell water potential and as a result of other 3 forces like cell wall matrix forces. So that cell wall matrix forces also play some role with reference to increasing the water uptake by the seeds, particularly some cell organelles like the mitochondria, ribosomes and spirosomes. They have a well developed membrane. So they have a well developed membrane, so that membrane also have some charges. So all those charges help the seed to attract more water molecule. The charges available in the mitochondria, ribosome and spirosomes help or that will show more affinity towards water. So that leads to increasing the water pulling power of the seed system. So that will attract water molecule. So by that way that will speed up the imbibition process. So that is a role played by the cell wall matrix forces. The another one is a cell osmotic concentration. So cell osmotic concentration, so this is going to play a major role in most of the seeds, most of the crops. The cell osmotic concentration is a deciding factor with reference to whether that water going to enter into the seed system or water going to come out of the seed system during the process of the imbibitions. So normally if you soak the seeds in the good quality water, means normally during that imbibition process that water will move from low concentration to high concentration. Here what we expect is the water should enter the seed system from outside. So if you are going to place the seeds in the soil during sowing means for in order to occurrence of that seed germination, whatever that water available in the soil, that should be entered into the seed system. So that and all happen only if your seed sap concentration is more when compared to that soil water concentration. So low to high, here that water will enter. In some other cases like salt affected soil conditions, that soil will have some water, and seed, whatever the seed you are going to sow, that also going to have some amount of the water. So if you compare that seed sap concentration with the soil water concentration, the salt affected soil condition, the soil water concentration will be more. At the time, instead of water entering into the seed system, whatever that moisture available in the seed system, that will come out of the seed system. And this is, I can say, it's a dysentery for the seeds. If it is going to happen, this kind of process also known as the reverse osmosis. So the dysentery or reverse osmosis is going to happen in the seed system, means that seed won't germinate, that will die. So this is the major problem whenever we take up sowing under salt affected soil condition. So under this situation, we have to regulate, or we have to increase the seed sap concentration. After increasing of that seed sap concentration only, we have to go for sowing of the seeds under salt affected soil conditions. Without increasing that seed sap concentration higher than soil water concentration of the salt affected soil, if you go for sowing, you cannot get any germination. So that cell osmotic concentration also going to play a major role with reference to that entry of water into the seed system during the process of the imbibitions. And then another one is a cell turgor pressure. So this is a regulating pressures. Once that water started to enter into the seed system, the cell membrane, it's a membrane that have a elasticity. So as and when that water molecule keep on going to enter, so this will expand. The membrane will expand just like a balloon. So that also have a maximum capacity. Once that attain maximum capacity, automatically that membrane started to exert the opposite forces also, that will started to resist the water entry. So once that cell turgor pressure is started, that is created, automatically the further entry of the water will be prevented. Here we understood that so the seed also attain maximum water absorption capacity. So even beyond that, if you try to give or you try to soak the seeds in the water, means what will happen? So that elasticity will be lost, so membrane integrity will be, structure will be collapsed, seed coat will be ruptured, so everything will be collapsed, the seed will die. So here that cell turgor pressure going to act as a regulating force. Okay, as and when that seed attain its a maximum capacity, automatically the cell turgor pressure that retard the water absorption. So this is a controlling mechanism. So the osmotic concentration going to help the seeds to uptake the moisture, and as and when that attain maximum capacity, with the help of that cell turgor pressure, that retard the further entry of the water. So this kind of peculiar and unique mechanism is there. I mean, peculiar mechanism, so wonderful mechanism is there in the seeds. So that will regulate and that viability and structural integrity of the seed system during the process of the imbibition. So once that the seed attain to the level of maximum water content, say example 60% and above, the seed will enter the next system. So here in this diagram you can see that triphasic pattern of the water entry into the seed systems. Whatever that we were discussed under the title of imbibition, that is up to this stage. So the seed attain maximum, the turgor pressure will be in action. So at the time the seed attain that almost plateau with reference to water intake. Then after some times again that will be there is an increase in the water uptake. I will come to that one later. Now we will discuss up to this. So this kind of increase will be recorded during the process of the imbibition. Whenever that seed system going to have that turgor pressure in action, at the time that water intake will attain the constant plateau. So this area we are going to discuss in the upcoming slides. So once that seed obtained the moisture content of that 60% through the process of that imbibitions, particularly in the case of a monocot, the scutellum and embryo get activated. The scutellum particularly that give a signal with reference to that GA3 production, gibberellic acid. So that gibberellic acid, in short call it as a GA3, that play a major role or that will regulate the germination process. So the plant growth regulator associated with the seed germination is a GA3, gibberellic acid. So that gibberellic acid produced by that scutellum that will get diffused in the endosperm area. So that will be get diffused in the endosperm area. So there that will activate the formation of the or production of the hydrolytic enzymes. Hydrolytic enzyme with reference to carbohydrate is concerned, alpha amylase, beta amylase, maltase, sucrase, like that. So many hydrolytic enzymes are there. With reference to lipid, lipase. Lipase is that hydrolytic enzyme for degrading that lipids and the oil molecule. Similarly, for protein, it's a protease, deaminase, like that. So many enzymes are there. So all those enzymes were produced in the endosperm area. So the produced hydrolytic enzyme started to convert that complex carbohydrate that is available in the form of starch. So that will be converted into maltose. Again, that maltose will be converted into glucose. Again, that glucose will be transferred into the embryo region. So where again in some of the cases for easy transfer of the carbohydrate molecule from one cell to another cell, the glucose will be converted into sucrose, because that sucrose is highly mobile, so that able to move from one cell to another cell at a faster rate. So because of that, glucose also sometimes converted into sucrose. Again, that sucrose reaches that living cell area. So that will be again converted into glucose. That glucose will enter into the glycolysis process. So that glycolysis process that will generate the ATP molecule. If it is a prokaryote, that will generate 38 number of ATP molecule. If it is a eukaryote, there we can expect the 36 number of the ATP molecule. So these ATP molecules and all given to the embryo for its further reassumption of its growth and cell elongation and rupturing of the seed core. So this is with reference to that carbohydrate. Similarly, the oil, lipid molecule available in the seed systems also broken into fatty acids and glycerol. Fatty acid and glycerol with the help of the lipase enzymes. Again, that fatty acid will undergo a further breakdown, so that leads to formation of the acetyl CoA. So the acetyl CoA is a precursor with reference to that Krebs cycle. So that will directly enter into the Krebs cycle, or some of the instance that will be converted into sucrose. Another way that fatty acids will be converted into triose phosphate. Then again that triose phosphate will be converted to glucose. Then finally that acetyl CoA or glucose, everything will be converted to sucrose or acetyl CoA and directly enter into the Krebs cycle, by which that also yield a energy molecule. So this and all with reference to degradation of the lipid at the time of the storage with the help of the hydrolytic enzymes produced by the seed systems. With reference to that protein is concerned, the protein is polypeptide molecules. So the polypeptides are broken into peptides with the help of the peptidase enzyme. Again, that peptidase will break that peptide into amino acids. Again, that amino acids are broken into amides, and then amides will be used for construction of a newer protein molecule as well as enzymes, because the protein is that going to give that body building functions. So whatever that amino acids or proteins are formed through the process of the degradation, that will be very well utilized by the embryo for the purpose of the development of the root and shoot. Okay, so this will be fully utilized for the body building function. Or sometimes the part of that amino acids also converted, that acids will be used for energy generation purpose also. But most of the protein molecules, the breakdown product of the proteins, that is available in the form of the amino acid. So all those amino acids will be utilized by the embryo for the purpose of body building function. So this is happening inside the monocot. Similar kind of event also normally occur in the case of a dicot. So this is a soybean. Same event is occurred here. So there that food material is stored in the endosome. Here that is available in the cotyledon. So here also the same event. The starch with alpha, that alpha amylase and beta amylase, that will be converted to glucose. Again glucose will be converted to sucrose for easy transport. Again that sucrose will reaches that living area of the primary embryonic axis. So that primary embryonic axis that will undergo that glycolysis process that leads to generation of the ATP molecule. Similarly, that lipid molecule also they will follow same process like that of the monocot. So here also fatty acid and glycerol. Again that fatty acid undergo degradation that leads to acetyl-CoA formation. Then acetyl-CoA will be directly enter into the Krebs cycle, or that will be converted to sucrose. Then again the sucrose will enter into the glycolysis that leads to generation of the energy. Whereas that protein that will be converted to polypeptides, that will be converted to peptides, then that will be converted to amino acids, amides. Both amides and amino acids will be used for formation of a newer protein through the process of the translations. So those proteins will be used for bodybuilding functions, for development of the root and shoot. So these are all the things will take place immediately after that imbibitions. Now that embryo is given with adequate amount of the energy molecule. So now that embryo fully loaded with the energy. So these are all the biochemical events with reference to conversion of that whatever that things so far we have discussed. The carbohydrate, fat and some of the protein molecules will be broken. That leads to formation of that ATP. That ATP will be used for the that embryo for its further growth and elongation and rupturing of the seed coat. So this is with reference to that fat hydrolysis. So with help of that lipase enzyme, the fat will be divided into 3 molecules of the fatty acid and 1 glycerol. So again that fatty acids will undergo 2 type of oxidation. One is that beta oxidation, one is that alpha oxidation, another one is a beta oxidation. Alpha oxidation is not a commonly occurring event, but some of the crops like sunflower and groundnut, occurrence of these particular event is recorded, alpha oxidation. So that alpha oxidation process, what is happening is that fatty acid will lose 1 carbon atom and carbon dioxide with the help of that fatty acid peroxidase enzyme and aldehyde dehydrogenase enzyme. So that leads to formation of the fatty acid peroxidase. Whereas in the case of beta oxidation is a very commonly occurring event in the case of the most of the oil seed. So here that fatty acids will be converted into acetyl-CoA. So the acetyl-CoA will directly enter the Krebs cycle that will generate the energy. Or sometime that acetyl-CoA will be entered into the clay oxalate cycle. So it's a somewhat complicated system. Through that clay oxalate cycle, that maltase will be formed, then oxaloacetate, PEP, phosphoglyceraldehyde, triose, that hexose, and finally this is also going to produce a sucrose. So the sucrose will enter into the glycolysis, automatically that energy will be generated. So these are all the things is very regularly happening, even though that 2 possibility of oxidation reactions are there with reference to oil, but beta oxidation is a very commonly occurring event. Through beta oxidation that going to have acetyl-CoA, that acetyl-CoA directly either directly enter into the glycolysis Krebs cycle, or that will enter the clay oxalate cycle. As outcome of that clay oxalate cycle entry, that will generate sucrose. Again that sucrose going to enter into the glycolysis process. So this is with reference to fat metabolism. Coming to that protein metabolism, here that 3 major process, deamination, transamination enzymes, then direct utilization of the protein molecule for newer protein synthesis. So if at all any deamination is going to take place, means the protein will yield ammonia and carbon skeleton. So these ammonia and carbon skeleton will be used for various metabolic activity. Suppose that transamination enzymes going to in action, means that protein will yield some keto acids. That keto acids will enter the Krebs cycle, through that will generate the ATP. Okay, so this is the only possibility with reference to extraction of the energy from the protein molecule. But most of the protein and their broken product is mainly used for bodybuilding function, particularly that is germinating seeds for the purpose of giving a size and shape to the root and shoot, and that whatever that proteins are protein or amino acids are produced, that degradation process that fully utilized. So these are all the biochemical changes that took place within the seed system. At the end of the process, that embryo will be given with enormous amount of the ATP. So with the help of that ATP, that embryo will initiate the its further growth, that reassume its growth. Here you can see. So after generation of adequate amount of the energy, so the embryo will reassume its growth. So reassume its growth. So cell elongation will take place, and organogenesis also will take place. Once that embryo started to elongate, that root and shoot region of the embryo started to elongate, means that seed coat not able to maintain its structural integrity, because now that pulging going to take place because of that elongation of the embryonic regions. So once that seed coat not able to withstand, mean that seed coat get ruptured. At the time of rupture, that most of the cases that radicle will come out first. The radicle will come out first, except rice. In the case of rice, that plumule will come out, whereas in the case of most of the seeds, the radicle will come out first, and then that plumule will come out. So finally you can see a beautiful seedling. So these are all the things happening at the time of the germination in almost all the monocot and dicot seeds. So these are the 5 different phases of the seed germinations. So this is the outcome. So rupturing of the seed coat and emergence of the radicle, followed by emergence of the shoot system. Finally, the seed analysis, they look for whether the seedlings are normal or abnormal. If it is normal, they will consider this particular seed as a germinable one. So this is overall events that is associated with the germination and the post germination phases. So this also given in correlation with that water entry into the seed system. So this is a thing represent that water availability in the seed system. So this is the first phase of the seed germination. So imbibition, the water will increase. So when that turgor pressure going to in action, at the time that water entry and water content of the seed will attain somewhat constant. So during that process only, whatever that biochemical changes we were discussed, everything going to take place. That is a breakdown of the carbohydrate, lipids and protein, everything will take place. And the energy generation and the cell elongation, everything will take place in this particular stage. So whenever again that water content of that seed increase, that indicates that seed coat going to rupture, that root and shoot going to come out. So once that seed coat rupture, there will be a entry of water into the seed system through mass flow action and the emergence of the root and shoot that ultimately demands more water. So this will increase. So here all the changes associated with the germination and the post germination process are given very clearly. So first one is the imbibition, then followed by the conversion of the complex material into simple material. So simple material will be available immediately, that will respiration will be take place. So the mitochondria, so that glycolysis process will take place, and that energy will be available, DNA repair will be take place, and DNA synthesis also will take place, and translation or degradation of the stored mRNA. Translation normally occur, that leads to formation of newer protein molecules. So transcription of mRNA, that embryo expansion that going to take place, and then rupturing of the testa and radical emergence, rupturing of the testa. So that is a seed coat and radical emergence, and reserve mobilized in the storage endosperms. Completely that will be utilized. Finally, the seedling growth. So these are all the triphasic pattern of the moisture absorption and corresponding biochemical changes associated with the seed germination. Thank you very much for your attention.